Hi. So this video is about to install AKS and the Azure Resource Bridge using PowerShell onto an AzStack HCI system. And for this, first of all, what I do is I prepare some things, which is launching a PowerShell window and then opening up Notepad in order to copy and paste some code, which is on this GitHub repository. The script that we are using is the AKS plus Azure Resource Bridge PS1. Download that one or copy and paste that one in raw format and bring that over to your AzStack HCI node. So this is either one or the other, or one of the nodes that forms your cluster, right? And we are going to not run all in at once. We are running this in pieces. The pieces I have specified in snippets. And first of all, we do the requirements, which is installing some or updating the latest or setting the PowerShell repository, which is filled from our product group guys with the right code to install AKS and to update the latest PowerShell package manager that enables us to download the resources from there. Okay, hence we need to close that PowerShell session in order to get the new PowerShell package manager. Therefore, the exit and then the new PowerShell window. Okay, with that, let's just check if we have that module installed. As there is nothing loaded, we only see the read line in there, but the module is there. It was updated. Let's search for it. And there you go. The 2.2.5 is the one that I installed right just a few seconds ago. It might be a newer one on your system depending on the time when you are running that installation. Okay, next thing is to install the module that enables us to install the Azure Kubernetes system on HCI, and the name for this one is AKS HCI, and it lives on the PowerShell gallery for this. However, this one requires some other modules or some other packages to be downloaded. The good thing about it is that it does that by itself. There is an accept license switch on this command, as usually you would have, accept the EULA for this. However, you can even omit that check with the accept license switch. Okay, now let's see which kind of commands are part of that module. And you could see, for example, it does have some install features, new features, remove components. If you want to have a look where it is installed, I would encourage you to go to the Windows PowerShell directory and the program files, go under modules, and there watch out for the AKS HCI ones. The AZ AKS is the one for Azure. The AKS HCI one is the one for your cluster. But there are other components like the mock and the KDA module, which from the time it is installed, you could tell it was installed currently ago. It might get updates frequently as our guys, as the devs are updating components to it. So it might be a good thing in order to update it from one time to another. So then I'll use a get option function, which I have created as part of the script in order to provide you some menus, all right? And so what it does is, the first parameter, it takes a command, and the second one is a filter, sort of, right? And what it gives you is, it puts all the output, gives some numbers to choose from, and basically, depending on which choice you're making, you get the value back, right? Which is some sort of nice way for the user input or for dealing with the user input. Rather than hard coding the stuff, this gives me the option in order to be a little bit flexible on this one. Okay. The device login is then for, as we are installing the Azure Stack or the Kubernetes service, which is also a hybrid service. That means it is talking to Azure. Why? Because it also reports usage. Why? Because it's reporting, it's being billed against your Azure subscription. It needs to register against your Azure subscription. Therefore, you need to log in, and this is done on the node, or you initiate, the device login on the node, and you could copy and paste, the code to another browser window at another session. Then we do register the resource providers, which may be an operation that is quite fast, depending on if that has been done already. Then for the setup to work nicely, we need to make sure that we have initialized the AKS HCI nodes, which is basically checking if remoting has been enabled, right? Not 100% sure if you need to run it on every node, but it's better to do so. So this is on the other node. I'll hop into the PowerShell and do the initialize AKS. And there, this command is, is part of the module that we have just downloaded, but we have downloaded it on the other node, so it's not there on this node. Hence, we need to, go through the steps of installing the prerequisites also on the other node as well, or on the other nodes that form your cluster as well. So let's fast forward this. As we need the new package manager for this, we also need to do it in 2 steps, right? So first update the package manager, then close the shell, then open a new one, and then do the install of that module. That gives us the initialize command. So once the module has been installed, we are still on node number 2, and now we do the initialize host or initialize AKS HCI node. There we go. And it just checks if PowerShell remoting is enabled, so that the cluster, that the node who is installing AKS can reach out to this one and perform some steps if it requires to do so. Okay, back on the originating node, so the one that we are have used for starting this deployment, right? So this is node number 1. I'm now selecting or filling in a variable for my Hyper-V switch. So depending on how much you have played with your system, you get maybe only 1 output or maybe 2 output, right? But this is the compute switch. You should have at least 1 switch where your virtual machines could be connected to. And to be certain, this switch needs to be able to talk to the host, right? So you can't spin up a isolated network, because the virtual machines that will be created as part of the AKS system need to talk to the nodes, to the host itself. Okay, so let's dig into some variables here. So first of all, the DNS server, which is your domain controller, right? So the one that is deploying this script needs to be able to talk to have admin rights on the domain controller. Then you do have also a valid gateway because you're downloading stuff from the internet, and this is the gateway to use. So the cloud service IDR is an IP address that's free, and it needs to be one that is on the same network as your cluster nodes. So I'm filling in these as variables and create an object, a virtual network object. It's not an Azure virtual network, right? But it's more or less, it's the same name, right? So you do have a network which is an IP address range that you have specified, and from that IP address range, your AKS system will use IP addresses from. Okay, the most important command in this context here is the set AKS HCI config. This does some sanity checking here. Also, if if something goes wrong, that would you would need to fix your IP address settings here. But if this one goes green, that gives at least a good feeling about the configuration that you have. It writes out a config file on your cluster shared volume into the working directory. So you would see that there is something happening on that directory path. Might look a little bit different depending on the time when you look there. However, you should at least see something is happening on that directory. So the next thing is to select the resource group into which you want to register your AKS system. Right? I told you AKS is a hybrid. AKS on-prem is a hybrid service. That means it needs to talk to your Azure subscription. However, it needs to put an object into a resource group in there. And the resource group that we are selecting is, or that I'm selecting, is number 19. And that's it. Next one is to actually set the registration so that your AKS system is auto-registering once it's being installed in the next command. However, we need to do another logon because it might be that the one that is doing the registration is a different user from the one that has been logged on earlier. In my case, it's the same admin account to do so, right? So once logged on, the script should switch to the next command, which is the actual install of AKS HCI. It does some cleanup first, or it checks if there is some remnants there from previous installations. If so, it does clean up. Then it starts to download the mockstab cabinet file, which contains the generic service components. I would encourage you to have a look at the file share to see what happens. It might look a little bit different on your end, however, some content should be created there. Next thing is on the cluster, you should now see a generic service that has been created using that file that was just downloaded. So the errors that could occur is, either download was not successful, or you don't have the permissions to add that component or to that generic service within that cluster, or also just make sure that you have an IP address that sits on the same network as the cluster nodes, right? You should see at that stage also an entry in your domain controller, right? Which has partially the name of the generic service that you see in the cluster. If you can't live with auto-generated accounts, right, or if you do have a different naming scheme, you can work with pre-created accounts. So I would encourage you to look up the way of pre-creating cluster objects and pre-create that account and reference this within the set HCI config commandlet. So if the generic service has been created and you can proceed with the next step, which is a download of the first Kubernetes node, or at least it's the operating system that is being used for the AKS master node. Right. So in order for AKS to run on premise, we need to have a control instance. This control instance is a system that lives within a Linux operating system, and that Linux operating system is a virtual machine that is hosted on your AzStack HCI. This is basically the download of this one here. I experienced in the past problems with downloading this file, so if you run into any issues, give it a try. It has some auto curing functionality, so if the thing doesn't download, you might wait for another cycle. If it's still not downloading, you may break out the command and restart the install AKS HCI from scratch. Just retry the command, as this might give you a better result. If you have any firewalls in between, there is a URL list that you would need to open for this download to take place. And also the list is quite substantial, because not only this operating system is downloaded, but at a later stage there is something happening inside the virtual machine. Additional extensions are loaded to the Kubernetes system, and therefore also not only the host needs to be able to download resources from the internet, but also the virtual machines, or the virtual machine that creates the master node also needs to be able to download and resolve resources from the internet. So once the download has been finished, a virtual hard disk will be created out of it. So the zip file will be concatenated and then transformed into a virtual hard disk that could be used for spinning up virtual machines. This takes some time, so be patient on this one. Depending on your storage system, on the performance of this one, this could take up a little bit of time. So when it's telling you deploy appliance, that would be a time where you could have a look at your cluster again and see if a virtual machine has been created using that Linux operating system that we've just downloaded. Here we go. And if you have a look at the virtual machine and do a console window, you should see at least something happening here, and it welcomes you with the Mariner Linux version name, and we should see something is happening there. So first of all, there will be some connectivity checks that are going to be done. Once the connectivity has been established, there will be things happening inside the container or inside the virtual machine. Have a look at the IP addresses that are being used. These ones are the ones that you have specified in the variables before. They should match to your system, right? And hence the compute switch is the virtual machine switch to be used for that. And it needs to have connectivity to your node that is deploying or running the deployment script, right? So some things that need to fit together here, right? And this is one area of problems, right? So you can't spin up a fully isolated system here. Your Linux or your AKS system needs to be able to talk to the node that is running the installation scripts. And depending on the speed of your system, waiting for the APIs to come online may take 1 or more minutes, right, or a couple of minutes before the process, before the next step will take place. The job Azure Arc onboarding is one of the steps that takes a couple of minutes to perform. So be patient here as well. You may want to have a look into your Azure Portal, as sometimes your Azure Portal is faster than the view that you have here in that PowerShell window. So you might want to navigate to Azure Arc, Kubernetes, and watch out for any new GUID or server to or entry to appear. So the name of the object within the Azure portal should equal the name of the virtual machine. And just one thing, if you ever press the mouse button on the execution window, it will show up the select bar and progress won't be made within the output of that script. So watch out for if you have the select statement in there. Right, you can just release it back to execution if you hit enter or something like this, right? And one thing, even if the thing shows up in the Azure portal, the Azure Arc onboarding phase might take much longer, a couple of more minutes to finalize. So then there are some other components to be enabled, or some other deployments that take place, which are extending the functionality of the AKS system. The billing operator, for example, may also take a while to finish. And once that's done, that's the output that we want to see. So now let's do a sanity check of the other output or the other artifacts that have been created. We have that one in Azure, so you could see what agent is being installed, what Kubernetes version you're running, if it's connected or not. That means if it's online and can talk to Azure. We do have a total node count of 1. Let's have a look at the node. I think it was configured with 4 virtual processors. There you go. And with 8 gig of RAM. So let's go to the Windows Admin Center and have a look there, because it also has in the cluster view a plugin for the Azure Kubernetes service. And this one is gathering also the information of your local AKS setup and gives you also the connected state. Okay, another thing here is the host settings. I would encourage you to have a look in there, because we do updates for the Kubernetes version in regular intervals. And the easiest way to do the updates is from here. I believe, as this is a brand new installation, we should not see any updates there. However, in a couple of weeks' time, there might be an update, and you have the possibility to press the update button here. Finally, we see the update for this extension notification on the upper part of that window. So let's see, and hence, as we have the Azure Kubernetes service plug-in to be available, we'll do an update on this one. And that's basically it. So Kubernetes has been set up, and now we put the Azure Resource Bridge on top of it. We could run the optional part, which is to create a workload Kubernetes cluster. This is not the master node deployment. It does not have something to do with the AKS or with the Azure Resource Bridge. This is for your developers, right? So this is the thing why we are doing this. However, I don't do this. I'll start directly with the Azure Resource Bridge deployment. Not quite, because a lot of the things that are done with the Azure Resource Bridge deployment are done using the Azure CLI. So that means what happens if I don't have the Azure CLI on my system, I do even have some code to install the Azure Resource Bridge, the Azure CLI onto your executing node. So let's just execute that code and see what it gets us. So be a bit patient here. The bits transfer takes a while to start. However, it's a way to, download resources from the internet without using a browser on a system. Then it will install the Azure CLI. Last but not least, we are setting the path to the Azure CLI as environment variable. And with that, we have the things, or we need to do some preparation for the Azure Resource Bridge installation, which is selecting some paths or some resources within Azure, specifying an IP address range for the Azure Resource Bridge components, and then use Azure CLI to log into Azure and install some extensions. Okay, so quite a big part. So first of all, we are selecting the compute switch again. Also, the Azure Resource Bridge spins up a virtual machine that is the host for the components that run this functionality to, perform to control virtual machines on AzStack HCI using the Azure Portal. For this, we need to, spin up a virtual machine, and hence we need to also specify some parts with it. So basically, the setup is a little bit similar to the AKS setup. So there are things happening. Some parts are really similar. For example, that there is a Marin Linux virtual machine that is being created that hosts the Azure Resource Bridge components. It also requires some login to your Azure portal for registration. That's what I do here. And then it's installing some components. First of all, I think it might be a good practice to get rid of maybe old extensions if you're playing with the Azure Resource Bridge. Sometimes cleaning up from a previous deployment is wise. If that's a brand new system, I think you can just start with the extension add thing. However, there's often it doesn't happen to me that things work at the first place. So having some cleanup routines help. Okay, so let's go a little bit through the script. What happens here? The Azure Resource Bridge will spin up a so-called custom location which represents your AzStack HCI. So that could be your data center's name, your city where the HCI host sits in, or something like this. Give it something meaningful, because that is something that people will see later on. Then you specify the DNS server, which is your domain controller once again, right? And also you need another control plane IP to assign to the virtual machine that is hosting the components. Then not only one IP address is enough, you need to specify a small range. I think it could be even smaller than that one I have, right? The Azure Resource Bridge doesn't really require so many IP addresses. However, just make sure you know that the network settings are applied to your environment. Also, the host needs to talk to the virtual machine, to the Azure Resource Bridge virtual machine once again. So you can't do it fully isolated here. So if you are using VLANs, make sure that you have specified here. Then there are some extensions to be removed, right, to get rid of the old ones and then to upgrade those, or and also to register the resource providers within your Azure subscription to be able to talk to that it understands the new functionality provided by the Azure Resource Bridge. So that may take some time. The next section is the download of the Azure Resource Bridge appliance, which, as said, is the virtual machine or the operating system for the virtual machine. And that can also take a while. So like the installation of AKS, this content is stored on the Resource Bridge temp folder, and it's also a zip file which has multiple parts, which is then concatenated together once done. So be patient on this one. Once the zip has been concatenated, there will be a virtual hard disk created out of it to be used as an image for our Azure Resource Bridge VM. And this one would be put into some gallery folder on your cluster shared volume. Once this is done, we do then the setup of or the deployment of the Azure Resource Bridge virtual machine, and that can take also some minutes. And like the installation of AKS before, you will get another virtual machine within your HCI cluster, which is using a Linux operating system. And within that Linux virtual machine, the Azure Resource Bridge components will be installed, configured, and hooked up to your Azure subscription. So deploy appliance is the keyword to go to your cluster and watch out for the newly created virtual machine. Have also a look at your Hyper-V manager for the virtual machine. Look at the IP addresses that it's been using. And these are the ones that have been, or at least this is one of your range that you have specified in the Azure Resource Bridge IP pool space. It may be useful to, to adjust the size of this one at a later time. But as you could see, it's performing its stuff, installing components, and then we'll take it from there. I enhanced the speed for this one quite a bit, so for you to have at least a complete view, but from the minutes of the provisioning time, you could tell that this takes a couple of minutes to be provisioned. So be patient on this one. Compare the times to your deployment. Take the deltas. Okay. So after the appliance has been created, we'll do the next step, which is to create the Arc bridge, which is, the component within the Azure Portal. So we'll copy and paste that code. And that will also create something within the Azure Portal. So this step should be a bit faster than the previous one. Watch out for the state, and then you could also go to your Azure Portal under the Azure Arc component, the Resource Bridge preview. You should now see an entry with the status of its current situation. What we need to have is not the validating or waiting for heartbeat. We need to have it in the running state. So that will take about, I would say, 5 minutes. You can do a refresh of that status either from the Azure Portal, or you use that Azure CLI command for querying the resource bridge. Look at the status and wait until this one is in the running state. So we do have the heartbeat, the connecting or the validating, connected, and then I think it is the running state. So be patient on this and only proceed if this one is running. So now as it is running, we can proceed with the next step, which is to create the HCI VM operator, or to actually create the which is a component or an extension to the Azure Resource Bridge, which provides the virtual machine functionality. So another component will be installed or will be configured within the Azure Resource Bridge virtual machine. Shouldn't take too long. Watch out for the final statement, and the provisioning state should be succeeded, and the component was the HCMI VM operator. And it might be interesting, the version number of this extension, as with newer versions there come more functionality. This is the one as of state of the 12th of October 22. Once we have that, the next step would be to actually to install the custom location. So, in order to make your Azure Stack HCI system selectable as a target for virtual machines for the users, we create that custom location object within the Azure Portal. And with the custom location, there also come some settings about which networks are available on that custom location or on that HCI system, plus which virtual machine images are available for to choose from when creating virtual machines. And all holds the custom location, which is based on the HCMI VM operator namespace. Okay. This is the success message that we look for. Then next thing would be to have a look at the Azure Portal, how that looks like. Custom location, do a refresh here, and we see the HCI on-prem. You might give it a different name, something more meaningful for the users, because this is something that the people will see in a drop-down box when specifying the target. Right. So think of it like an Azure region where you're deploying virtual machines too. That could also be, something to use for. Then the next thing that we need to tell the Azure Resource Bridge is the virtual network, which is available for the virtual machines to be placed on. And that's basically our compute switch, or our, we want the virtual machines to be created on our compute switch. I think it is. Bear in mind or make sure that you're using case sensitive names. Yes. Let's run that. As I'm working with variables here. If you're using the script, you should, use you're also using the variables, and thus you make sure that it has the correct casing, because the Azure Resource Bridge is case sensitive, as far as I know. Okay, next thing, as we have the network, let's look at the Resource Bridge resources. There we have the compute switch as one necessary part to create virtual machines. And the next thing is to create a virtual machine image. In my case, this is a pre-configured Windows Server 22 VHDX virtual hard disk, which has been sysprepped, right? I put it on some folder on my cluster shared volume, and I'm telling the Azure Resource Bridge that this is my custom Win22 server, and it's operating system type Windows, and please add this image to the custom location. So if you want to have a look, this is the path that I was creating earlier, and I placed some images into this sysprepped virtual hard disk that you can create virtual machines from, and that's the basis of the gallery image item. Okay, so let's run this. Obviously, this is something that I prepared before. So in your case, you would need to create some virtual hard disk before. Either you take it from download section from Microsoft, or you are spinning up a virtual machine in Hyper-V, installing an operating system using an ISO file, then doing the sysprep, shutting down the thing, and copying over the virtual hard disk to that place. That's up to you, right? And the representation for the gallery image item is not uploading that virtual hard disk to Azure in some ways, right? It would not make any sense there. So this should be relatively fast. So it's just creating a resource in Azure, hooking up things so that Azure knows, when it comes that a user creates a virtual machine from the portal, that he knows which physical file or which file this is on premise. So yeah, let's try this. So now let's go to create a virtual machine from it, because we now should have everything in place for the Azure Resource Bridge. And I'll create a resource group that should act as a container for my artifacts. Although the virtual machine is being created on premise, it still creates some artifacts, some placeholders in Azure. And I'm giving the virtual machine a name. Here we do have the custom location tag. I only have one custom location. That could be, the West Europe is the one specified by the location of Azure, which holds this object, but with a name, it could be your data center, or data center number one, or whatnot, which is more useful for your users. Then I'll give it an admin account, including the password. Hop to the next step, which is adding a disk. This is not the operating system disk. This is a data disk, an additional disk to the virtual machine, right? Let's give the disk a name and a size. So this is dynamic, which means thin provisioned The space will be eaten up when I begin to put content on this. Then a network interface for the virtual machine. Yeah, it needs to talk to the outside world, then this would be a useful thing, right? And here I do have my compute switch as the one and only network which I have given the custom location to put virtual machines on. You could have multiple ones, right? Also with VLANs. However, this is not part of this video here. And now I pressed the button. I think it's interesting to also mention that that you have a template approach for this. So this is the usual Azure deployment way of doing things, and it's also using ARM templates. Note out here that the Azure Resource Bridge has its own namespace or its own provider. And if I hit the create button, it will trigger off an Azure deployment, which then manifests in a virtual machine that is hosted on my on-prem HCI system. So here you go. On the HCI cluster, I see a newly created virtual machine with the name that I have entered in the portal. It already has been booted, and I now should be able to log on as the administrator that I have specified. Let's have a look at the virtual machine size. This is the 4 virtual processors that I have specified, the 8 GB of RAMs. Yeah, just like a usual Hyper-V virtual machine with the settings from the portal. And it may take a couple of time or some time for this one to finish. Once it's done, let's have a look at the resource group. The virtual machine is showing up here with a slightly different icon. This is not an Azure virtual machine, therefore it has a different icon. However, within 4 minutes and 16 seconds, this virtual machine was provisioned, and I now could, log into this box. And even with the account that I have specified during the setup, so I'm typing in the password for the admin user, and there we go. So that was about creating Azure Kubernetes services plus the Azure Resource Bridge on top of an HCI system using PowerShell. So hopefully you would be able to copy that. Wish you all the success for this. Take care. Bye-bye.